Welcome to Section 3 of Experimental Psychology, Psych 224. In this session, I'll talk about the nature of scientific methodology. So Christensen identifies three main characteristics of the scientific research. He talks about control, he talks about operational definition, and he also talks about replication in research or experimentation. So that is what this session will cover. And then I'll also talk about the steps in scientific methodology, take you through the various steps that you need to follow when you want to conduct research. I'll talk about the characteristics of scientific research, the steps in scientific methodology, and I'll briefly talk about researchable questions or topics. By the end of this session, you should be able to explain the three characteristics of scientific methodology. You should be able to use a diagram to outline the steps in scientific methodology, and also use your own example to outline these steps in research. Before I go on, these are the reading lists. Make sure you read these chapters in these books. So let's look at the characteristics of scientific research. As I mentioned earlier on, Christensen identifies three most important characteristics of scientific research. So he talks about control, operational definition, and replication. I'll talk about each of these three. I'll start with control. So basically, control talks about eliminating extraneous variables. I think I've mentioned over and over again about extraneous variables, that they are variables that are not of interest to the researcher but can affect the outcome of a study. And that is the reason why they have to be controlled or eliminated in experimentation. Once a researcher is able to eliminate or control extraneous variables, then a cause-effect relationship can be identified. So if an experiment is not well controlled, then it means that we cannot isolate the cause of an effect. It means that the observed effect may be due to other variables other than the independent variable that we are interested in investigating. Again, when we talk about the effect of alcohol on task performance, we can have extraneous variables such as prior exposure to the task or tolerance to alcohol intake being extraneous variables. So when we talk about prior exposure, again, if it's a task that the participants have already seen or performed before, then they'll have it easier, or they'll find it easier performing this task. Again, if let's say you have a group of participants among your participants who have high level of tolerance to alcohol, it means that perhaps no matter the amount you give to them, it will not affect them in any way. And so you have that alcohol tolerance being an extraneous variable that have to be controlled. So in this case, it means that you take people who have the same level of tolerance to alcohol, so that does not become an extraneous variable. The second characteristic that Christensen talks about is operational definition or operationalism. So this is basically defining of concepts by the operations that are used to attain or measure them. And in scientific research, operational definition is necessary to eliminate any confusion in communication. So sometimes there are terms that we would use in experimentation. We have to define these terms so that if a reader picks up our research report, they know what we mean by these terms. So for instance, if we say that alcohol intake will increase performance on a task, that is the research that we are interested in investigating. So we have a hypothesis that says that individuals who take in more alcohol will perform poorer than those who take in less alcohol. Now the question is, what is our definition of more alcohol and less alcohol? We want readers to be able to understand what we mean by more alcohol and less alcohol so that there's no miscommunication. So in this case, we would operationally define what we mean by more alcohol. Do we mean 5 bottles of beer or 2 bottles of beer, etc.? If we say less alcohol, do we mean 1 bottle of beer or 2 bottles of beer, etc.? So it's important to operationally define terms when you are doing research. The third one that Christensen talks about is replication. So when we do scientific research, the data that we obtain must be reliable. It means that if we are to repeat the same research using the same steps, we should be able to obtain the same kind of results that was obtained initially. So replication is performing the same experiment using the same procedure to find out if the same results will be obtained. So it's basically duplicating the results of a study. And if we have to obtain the same results, it means we have to use the same procedure that was used previously. And when you do replication in scientific research, there are two possible outcomes. It's either the initial results are replicated or they are not. So when the initial results are replicated, for example, if we find out that those who take in more alcohol perform poorer than those who take in less alcohol, then it means that our initial findings have been replicated. Now, if initially we found out that those who take in more alcohol perform poorer than those who took in less alcohol, and then we replicate the study and we find out that actually there's no difference between the two groups, it means that we did not obtain the same results as we did initially. When we obtain the same results, then it gives additional assurance that the initial results we obtained are reliable. Now, if we don't obtain the same results, so if the results are not replicated, there are two possibilities. It is possible that perhaps in replicating this experiment, we may have altered certain significant elements in the experiment that has altered the outcome of the study. So, for example, let's say the instructions that we may have given to the participants was different from what we gave in the initial research that we did, or we used different types of participants. Perhaps we tested older people, now we are testing younger people, and so that has affected the outcome of the replicated study. It's also possible that perhaps the initial results that we obtained was just by chance. It's just by chance that we found out that those who take in more alcohol perform poorer than those who take in less alcohol. So that is it for replication. It's either you find what was found initially or you don't. Now let's look at the steps in scientific methodology. So Christensen identifies 5 steps in scientific methodology. And so I'm going to talk about each of these 5 steps. So identify a problem and formulate a hypothesis, design the research, conduct the research, test the hypothesis, and communicate the research results. So let's look at the first one. So every scientific research begins with identifying a problem. There should be a problem that you are interested in investigating. So you have to identify a problem. And you identify a problem sometimes by studying or observing things that happen in our everyday life, or you do so by reading previous research that have been done. So you have to do a literature search. So once you've identified the problem you want to investigate, you try and refine and narrow that problem that you have identified. You can only do so by doing a literature search, reading previous research that has been done in that area to give you more information and to guide you to refine your area of interest or your research topic. Once you have done that, then you formulate your hypothesis. So you state your hypothesis in such a way that they are testable. Remember, I mentioned when I talked about hypothesis that they should be stated in such a way that you can confirm or refute the hypothesis. So the hypothesis should be stated in such a way that they are testable. It should clearly state the relationship between the variables that you are investigating and clearly state the outcome that you expect to emerge from the research. The second step in scientific methodology is designing the research. So here, the independent variable, the dependent variable, and extraneous variables are the 3 most important variables in the experiment that need special attention. What this means is that you need to know what your independent variables are. you need to know what your dependent variables are. So what are you manipulating as the independent variable? What are you testing as the dependent variable? And what are the extraneous variables that can affect the outcome of the study that you have to control? So as a researcher, you must decide on the design of the research. So once you've identified the variables that you want to investigate, you have to determine, am I going to use a qualitative research design? Am I going to use a quantitative research design? Is it going to be an experimental study, or is it going to be a correlational study? So you decide the kind of method that you are going to use. Now, these steps are extremely important to the conduct of the research because you have to outline how you are going to go about the research. Once you have done that, then you can carry out the research. So what it means is that if you are not able to outline the steps that you are going to follow to be able to do the research or collect your data, if you don't do that well, it means that when you collect your data, you may not be able to get valid data, and then you might have a lot of limitations in terms of your research findings. So once you've decided on the steps in how to conduct the research, then you go ahead and conduct the research. So in the previous step, you've made decisions about which participants you are going to test, what instructions you are going to give, and then what equipment or materials you are going to need. Once you know all of this, you go ahead and then you collect your data, or you conduct your research. In conducting the research, you are collecting your data to be able to analyze the data and come out with your findings. So first of all, you have to select your participants in this step, and then you manipulate your independent variable. So for example, are we testing different levels of alcohol? If we are saying that those who take in more alcohol will perform poorer than those who take in less alcohol, how are we manipulating alcohol? Are we going to have 3 groups? Those who take 1 bottle, those who take 2 bottles, and 3 bottles of beer? Or are we going to have only 2 groups, those who don't take alcohol at all and those who take alcohol? So we have to manipulate our independent variable. And then we ensure that all extraneous variables have been controlled. Then we measure our dependent variable. Usually the dependent variable will be one of these 3 types. It could be self-report measures, there could be behavioral measures, or physiological measures such as, for instance, a glucometer to check individuals' sugar levels. It could be a biofeedback machine, among others. I would like you to read more about these 3 and discuss them during tutorials. Now let me talk about the 4th step, which is testing the hypothesis. So we've identified our problem, formulated a hypothesis, and then we've conducted our research. So now we have to test our hypothesis. So we do so by analyzing the data that we have obtained. When we measure the dependent variable, we obtain data, or we obtain information, and this is what we analyze to interpret them to see whether our hypotheses have been confirmed or they have been refuted. And usually we would use a statistical software to analyze our data. More often than not, psychologists, we rely on SPSS, which is the statistical package for social sciences. So we use SPSS to analyze our data, and then we interpret the results that we obtain. But one thing you need to notice that in as much as you use SPSS to analyze your data, as a researcher, you would have to determine what type of analysis to do. So there are several analyses you can perform. A t-test, you can perform ANOVA, one-way ANOVA, two-way ANOVA, correlation, etc. You have to determine how best to analyze your data. Then the last step in the scientific methodology is communicating the research results. So here you write a research report on what you have found. So basically, you are communicating to other people the findings that you have obtained. So you talk about what you did, how you did it, and what you found. I'm not going to talk too much about this because I will talk about this in the last session, which is session 11, about how to write a research report. Now, it is not enough writing the research report and printing it out or binding it into a book. It's important that you publish these results so that other people can also read these results. And you do so by publishing the research in a professional journal. So depending on your area of study, for example, if you did something in clinical psychology, you will look for the Journal of Clinical Psychology to publish your results in. So depending on your research area, that will determine where you publish your results so that all others can read about your findings. Now I'm giving you this example. So use the 5 steps I've just described to work out how you conduct a study such as this, which is the effect of eating breakfast on students' learning. Remember the steps I talked about. I've put it in a diagram form. So first you identify a problem and formulate a hypothesis. You design the research, you conduct the research, you test the hypothesis, and then you communicate the research results. So I want you to use this topic, effect of eating breakfast on learning, and try and outline how you would conduct such a research using the steps that you see on the screen. So this brings me to the end of steps in scientific methodology. I'll move on to talk about the last thing in this session, which is researchable questions. I'm going to briefly give you examples of researchable questions, because sometimes when we phrase our research questions, we phrase them in such a way that it's difficult to be able to actually investigate them. Remember I said when you identify a problem, you need to refine the problem. So let's see some researchable topics and topics that may not be researchable because of the way they have been put. So ensure that your research question is researchable, as I have said. And researchable topics are those that can be investigated empirically. So a good research question should be feasible. It should be clearly stated. It should be significant, and it should be ethical. So for example, talking about conducting an ethical research, if you want to look at the effect of divorce on children of the divorcees, you cannot conduct an experiment, because you cannot get people to say we are getting divorced and we want to see how it will affect our children. That is not ethical. So you would not use an experimental method in this kind of research. You would rather use maybe a survey and then give out questionnaires to people who have been divorced or their children to assess the impact it's had on them. So examples of researchable topics. For instance, you can have which approach taken by University of Ghana will be the most effective way of ensuring cleanliness on campus. So in this case, we can say that we are having a cleanliness competition and then get all the halls of residents involved and then give them some criteria they have to meet. At the end of the day, we can do that by having different criteria. We can say that for this hall, we are going to have bins all over the hall. For this other hall, we are going to have the bins only outside at the Porter's Lodge, among others. So we'll use different methods. And then for other halls, it will just be information that will be on the screen at the Porter's Lodge every time to sensitize people. And then we'll test these 3 different methods to see which will be the most effective way of ensuring cleanliness on campus. We could also investigate what the effect of knuckle cracking will be on the development of osteoarthritis among males and females. So you compare males and females who crack their knuckles to see the effect it will have on them. We can also investigate how employers perceive first-class honors students. So these are researchable topics. Now let's look at topics that may not be researchable. Non-researchable problems include explanations of how to do things. Non-researchable topics are vague propositions. They address philosophical or ethical issues, or they just address opinions, so they cannot be solved through data collection or analysis. So for example, you have topics such as what is the best way to learn to read? It's very vague. How do you test a research topic like this? Or are some people born bad? How do you investigate that? Or can crime be prevented, among others? So flipping this coin to looking at how to phrase these research topics to make them more researchable, we can say, for example, in terms of crime, are the poor more likely to commit crime than the rich? So you compare rich people and poor people, or people from the rural area and people from the urban area. So your research topics have to be researchable so that you can conduct your research. So this brings us to the end of this session.